Okay, so in this problem, we are on problem number 5. We want to find the area of the shaded region in the figure. And it says use the pi key for pi. Don't use 3.14. And so it looks to me like what we have in the shaded region is we have a circle, and then we have a square that's cut out of that. So to find the area, so what we need to do is find the area of the circle, and we need to subtract the area of the square. Okay, to find the area of the circle, you want to do pi r squared, where r is the radius. To find the area of the square, you want to do the side length squared, or side times side. And so in this case, we would do pi times the radius. Well, what is the radius of this circle? It looks like the entire thing is 6.9 feet. So that would be the diameter. So we need to find the radius. Then we need to take the diameter and divide it by 2. Well, that's going to be 6.9 divided by 2. And that comes out to be 3.45 feet. So we want 3.45 squared minus the side length of the square squared. So this is 3.5. Okay, and I honestly would type it in my calculator exactly like this. So you want to make sure you use the pi button. Okay, I'm getting a really long decimal number, 25.1428, and it continues. And in this problem, they're instructing us to round that to the nearest tenths place, so that's going to be 25.1 feet squared is the area of the shaded region in that circle. So what is the total length of a belting needed for the pulley shown to the right? So what we're looking for is the distance around this whole belt. What I know already is we've got to at least have 70 inches and 70 inches. Okay, so this thing is made up of these sections that are 70 inches. We have 2 of those. Okay, another thing that it's made up, if you'll look closely, is we have a half of a circle on both ends of the belt. And if we put all that together, we would have our total belting. So we know that we've got to do our 70 inches plus 70 inches. Plus, we've got 2 half circles, and we have to put in the length of those 2 half circles. Now, the circles are the same, so I guess the 2 half circles are the same. So if you put them together, right, if we stick the 2 half circles together, we would have a whole circle. So to find the length of the distance around, you're really talking about circumference. And to find the circumference, it's 2 pi r. Okay, and so we've got 2 times pi, and we do have a whole circle when we put them together. The radius, well, they give us the diameter here. The distance all the way across the circle is 14. So if you're given the diameter and you want to find the radius, you would need to divide by 2. So the radius is going to be 14 inches divided by 2, which is going to be 7 inches. So our radius is 7 on that. And if we find just the one circle, since the 2 of them together make 1, we're only going to have to add on that unit. So we've got 2 times pi times 7. Okay, I'm coming up with 43.982, and it just keeps going like that. So when I type this in, I'm probably just going to leave it. I would type it in as 14 pi, so I get a more exact answer. Okay. So when we add these things, I'm coming up with a 183.9822, and it just keeps going. They do give you the directions to round to the nearest inch, and so we would, since this is a 9, we would say 184 inches on this one. Okay. Number 7 says, how many cubic feet of warehouse space, so we're talking about cubic feet, we're filling something up, we're talking about volume, are needed for 260 boxes that are 19 inches by 8 inches by 11 inches. So first we would find the volume of one box. So we'll start out by finding the volume of one of these boxes. And we would do that by saying 19 inches times 8 inches times 11 inches. Well, inches times inches times inches is inches cubed, or cubic inches. Then when we take our 19 times 8 times 11, we come up with 1,672 cubic inches. Okay, so that's how much space that one box takes up. Well, we have 260 boxes, so we would do 260 times 1,672 inches cubed. Okay, and that is 434,720 inches cubed. Now, the question asks us how many cubic feet. Okay, so we know that there are 12 inches in 1 foot. So if we cube both of these, or raise them to the third power, that means that 12 times 12 times 12 is 1,728 inches cubed. And 1 times 1 times 1, right, if we cube it, is 1 feet cubed. So there's 1,728 inches cubed in 1 foot cubed. So I need to take my 434,720 inches cubed and divide it by 1,728 inches cubed to figure out how many feet cubed I have. Okay, I'm coming up with 251.0574, keeps going. So what do they want us to round to on this problem? It says round to the nearest whole number as needed. So on this one we would say 252 feet cubed, because the 5 would make us round that 1 up to a 2. What is the weight of the bushing shown below if it is made of steel weighing 0.2835 pounds per inch cubed? And it says the inner cylinder is hollow. So what we're going to have to do is we're going to have to find the volume of the big cylinder. And the formula for the volume of a cylinder is pi r squared h. R is the radius, h is the height of the cylinder, and when we talk about the cylinder, we're going to turn it upright, so the 8.5 would be the height. So what we're going to have to do to start off is we're going to have to find the volume of the big cylinder, and then we're going to have to subtract off this little cylinder that is in the core because it says it's hollow there. So minus the volume of the small cylinder. Okay, so we've got pi r squared h for the big cylinder minus pi r squared h for the small cylinder. Now on both of them, our height is 8.5 on this one. Okay, if you look at these cylinders, the big cylinder, the one on the outside, its height is 8.5. Even the small cylinder, the height is going to be 8.5. That's not going to change. Okay, pi is also not going to change on either one of these. So the pi is not going to change. Now the radius is. So if you look at the radius of the big cylinder, we've got 5. The diameter is 5. But to find the radius, you would take that 5 and divide it by 2. So 5 divided by 2 would be 2.5 squared. So pi times 2.5 squared times 8.5 for the volume of the big cylinder. Now when we want to look at the small cylinder, so the radius, the diameter of this is 2 1/4, the small cylinder. So we're going to take 2 1/4 and divide it by 2. I'm just going to not deal with the fractions and say 2 1/4 is 2.25 divided by 2. That gets me 1.125. I don't know if I'm going to be able to squeeze that in here, but 1.125 goes right here. Write that a little bit bigger. Okay, so I'm going to do this minus this. Let's see what we come up with. Okay, that total is giving me 133.100, and it just keeps going. I'm going to leave that on my calculator because it says that, and we found this is in inches cubed because we found the volume of this thing in inches cubed. Well, it says that there's 0.2855 pounds per inch cubed. So I'm going to need to take that number and I'm going to leave it on my screen, on my calculator, and I'm going to take this number and I'm going to need to multiply it by my 0.2835 to get however many pounds of steel that I'm going to have. So the problem says to round this to the tenths place. This came out to be 37.73, keeps going, but so dot dot dot. The 3 would leave the 7 alone, so I'm going to say 37.7 pounds. So we've got the volume, and we've got a conical oil cup. So we're talking about the shape of a cone. It has a radius of 6.5 centimeters. I'll draw this cone out. The radius of this cone is going to be 6.5 centimeters. It must be designed to hold 65 cubic centimeters. So this is the volume of oil. What should be the altitude of the cup? So the altitude is this height right here that we're looking for. How tall? What's the height of the cup? So let's fill in what we know. We know that the volume, so for volume we can fill in 65. Instead of volume I put 65, and we know that's cubic centimeters here. We've got pi. Our radius, which is the next thing in the formula, is 6.5. And we're squaring that, and then we've got our height, which we don't know, divided by 3. Okay, so we want to see if we can simplify this down some. Really, I can calculate everything except for the height here, so I can go ahead and get pi times 6.5 squared divided by 3, all times this height. Okay. 65 is equal to 44 when I multiply all this stuff together. 44.244, and it keeps going, times the height. So to get the height by itself, we really just need to take and divide by 44.244 on both sides of our equal sign. So to get the answer, we want to say 65 divided by 44.244, and you really want to just leave that on your calculator and do 65 divided by the answer that you had already on your screen, which would be the 44.244. Okay, that is getting me approximately 1.469, and it keeps going. This one's telling us to round to the tenths place, so I would say 1.5 centimeters would be my altitude, or how tall this cone would need to be to hold this 65 cubic centimeters if my radius is 6.5 centimeters. Let's find the depth of D. Find the depth D of the V slot shown in the figure to the right. Okay, so we're looking for this distance right here. Now, Okay, so to work this problem, we're going to want to use trig here. So we're going to use our trig sine, cosine, and tangent to work this problem. So I'm kind of pulling this triangle out, and I'm going to divide it in half. Okay, and when we divide that triangle in half, if this whole thing was 60, which is what it says here, then half of it, okay, just this little section right in here would be 30 degrees. Okay, and if I take the distance across this whole thing, which is 2 3/4 or 2.75, and I divide it by 2, that's going to give me 1.375, and then this side would be 1.375. Okay, so I'm just going to focus on one of half of this triangle. And this is going to be 30. And I'm looking for this, the height, the depth, which is what they're calling this D over here. So I'm looking for that. So I want to use tangent to find that. So tangent of 30 degrees. The tangent is the opposite over the adjacent on the triangle, and that's what I know. I know the opposite of my 30 degrees is 1.375, and I know that adjacent to 30 degrees is x. So I would do 1.375 over x. Now, we want to solve for x, so we're going to cross multiply. So we're going to say x times the tangent of 30 equals 1.375. Then to get this x by itself, we will want to divide by the tangent of 30. Okay, and so the part that you're going to type in the calculator is this 1.375 divided by tan of 30. You want to make sure that your calculator is in degree mode. If it is not in degree mode, it's going to give you the wrong answer, but 1.375 times divided by the tangent of 30. Okay, and it's having us to round this problem to the tenths place. No, to the hundredths place, sorry. So I'm getting 2.38156. So if you want to practice this one to make sure you're able to get the right answer on the calculator for the first thing. And so I would say that my depth is 2.38 if I'm rounded to the hundredths place, and we're talking about inches here. Okay. The most efficient operating angle for a certain conveyor belt is 39 degrees. If the parts must be moved a vertical distance of 29 feet, which is why they've got 29 over here, what length of conveyor is needed? So we're trying to solve for L. So in relation to this triangle, I have the opposite, and I want to find, so this is the opposite side, and I want to find the adjacent, no, sorry, this is the hypotenuse. And remember that the hypotenuse is always the longest side of the triangle. Know what I was thinking when I did that. This would be my adjacent side to 39 degrees. Okay, so I'm going to use what I know, which is my opposite and my hypotenuse. So the sine of an angle is equal to the opposite over the hypotenuse. So if I know the angle, the sine of 39 should be equal to the opposite, and for me, the opposite is 29, and L is my hypotenuse, so I'm going to be able to do 29 over L. Okay, so we solve this by cross multiplying, so L times the sine of 39 equals 29. To figure out what L is, I would want to divide both sides by the sine of 39. Make sure that your calculator is in degree mode before you type this in. 29 divided by the sine of 39. Okay, that's getting me 46.081, and on this particular problem, they're asking you to round to the nearest integer. So we would just say 46 inches would be our answer. Got 10 holes are spaced equally around a flange on a circle at a distance of 6 inches from the center. Find center to center distance x in the figure. So we're trying to find the distance between these two. Okay, so we're going to have to think about what we know here. I'm going to kind of pull out this triangle so we can talk about it, but this is what we're trying to figure out x. It tells us that on a circle at a distance of 6 inches from the center. So what we know there is that this radius, our radius is equal to 6. We know this side is 6. We're trying to find this side. We also can find this angle here because we know there's 360 degrees in an angle, in a circle, sorry. And we have 10 holes here, so we would divide by 10, and that would give us 36. So this right here has to be 36 degrees. So if we're trying to find x here, okay, we know parts of our triangle that we can use. So in order to do this, we need to divide this triangle in half. We need to cut it right down the middle so that we can make a 90-degree angle. So if we do that, make a 90-degree angle, what we know is that we would find half of x, right? So I'm going to just call this y, but we're going to find half of this distance. When we get done, we're going to need to multiply that by 2. And this is our 90-degree angle. 36, we were cutting that in half too, and 36 divided by 2 is 18. So this is 18 degrees. You just draw this triangle again real quick. So we're cutting this triangle in half. So we have, let me make it a little bit bigger. This is 18 degrees because we did 36 divided by 2. I'm going to call this y, but it's half of this x. And when we get the answer, we're going to multiply that by 2. This is still 6. This is our 90-degree angle. So what I know is I know my 18 degrees, and I want to find the opposite of the 18 over my hypotenuse. And so sine is equal to the opposite over the hypotenuse. So if my sine of 18 is equal to y over my hypotenuse, which is 6, I'm going to want to solve for y by cross multiplying. So I'm going to say sine of 18 times 6 is equal to y. Okay, so that's going to get me y is equal to 1.854, and then we know, and it keeps going, but we're supposed, that part's just y. So we're going to need to take that number and we're going to need to multiply by 2. So we want to take 1.854 because we want the whole x, and this is just the y part would just be half of it. So we want to multiply that by 2. And I'm coming up with 3.708, keeps going, but they want us to round this problem to the nearest tenths place, so we would just say 3.7, and this problem is in inches. Okay. So number 13 says, study this circle graph and answer the following questions. So you can see the percentages. It says, which category represents the largest expenditure? And it's kind of easy to see that the tuition category takes up the biggest chunk of this pie. So the answer would be tuition. Which category represents the smallest expenditure? Well, it looks, and you can even see the percentages, 8% lab fee, the smallest. The student spent a total of $2,500, so the combined amount that went towards tools and lab fees was. So on part C, we're saying that $2,500 is the total amount they spent, so that would be their 100%. Okay, but we want to know what specifically they spent towards tools and lab fees. Well, tools was 28%, and lab fees is 10%, so I'm going to need to do 28 plus 10 to get a total of 38%. So I could cross multiply this and do 2,500 times 38 is equal to 100x. And so we would need to divide both sides by 100. So 2,500 times 38 divided by 100 is $950. Okay, that's what. And then it says if a student spent $200 on materials, the amount spent on books and lab manuals was, okay, so what do we know about materials? Materials is supposed to be 10%, so I'm going to work part D over here. We know that materials is supposed to be 10% according to our graph up here. So materials is 10, then I want to know the amount spent on books and lab manuals. Well, books and lab manuals is supposed to be 16%. So I could cross multiply. 200 times 16 is equal to 10 times x. So we divide both sides by 10. $320 would be spent on the books and lab manuals then. Okay. This is multiple choice, so a table of values showing the number of community colleges in various regions in the country is shown to the right. Draw the related bar graph. Well, so we want A to be going up to about 8, and if you compare all these blue A's, right, they look about the same. They all look about like they're going to 8. Let's look at the red B category. B is supposed to be going to 10. Well, this definitely doesn't go to 10, so this is not it, right? This one goes over 10, so we know that's not it. And this one is right at 10. So we want to kind of eyeball the rest of them. C is supposed to be 6. That's good. D is supposed to be 7, slightly more. E is 15. Perfect, because it's going up to 15 right there. And then F is supposed to be 3. So C is the right answer for that. Okay. And the last question says to compare the cost of these with a double bar graph. So if you'll pay attention, we've got the blue is the cost of the regular gasoline and the red is the cost of the diesel fuel. So when you're looking at 2003, those are very close together. Okay, so but it says 1.42 and this one's going almost up to 2. So I don't think that that one's correct, right? So this one's going over 3. This one looks about right, and so does this one. So we know it's not this one or this one. Let's look at the second one, 2004. The blue, the regular cost of gasoline should be about $2, and the diesel fuel should be almost $2.25. So this one is going, the blue is going almost up to 3, and it's supposed to be, right? The blue is going up to almost 3, and it's supposed to be 2. And then, so that one's not it. So this one is, if you compare the numbers with what we have up here in our graph, this is going to be the correct answer. So that is the end of this chapter 8 through 10. So I would use these examples to work your other problems.